Hi students, my name is Dr. Dave, and I'd like to welcome you to my office, or what I like to call my mini science lab. Obviously, like many of you, my family and I have been spending a tremendous amount of time indoors. Now before I begin, I would like to express my concern and say that I hope that you, your family and your friends, and all of those that you hold close are healthy and safe during this time.
Over the past few months, you may have been hearing a lot about washing your hands and how washing your hands can help prevent the spread of COVID-19. But how is soap actually working to help the spread of germs? What is it doing on your hands to prevent you from getting sick? I'd like to spend a little bit of time exploring that today and hopefully teach you something along the way as well. Let's get started.
Have you ever wondered how soap was discovered and who made the discovery? What about the first person who thought about washing his or her hands? While we might never know the answers to these questions, soap has obviously become one of the most effective defenses against invisible and often harmful pathogens, otherwise known as germs. In the early 1800s, microbes were not widely recognized as disease-causing agents. However, during this time, some medical doctors discovered that if they washed their hands before surgery, far fewer patients died afterwards. Unfortunately, these doctors were ridiculed for suggesting that a lack of personal cleanliness could be responsible for their patients' deaths. In fact, it wasn't until the 1980s that the Centers for Disease Control and Prevention issued the world's first nationally endorsed hand hygiene guidelines. As we now know, washing our hands with soap and water is one of the key public health practices that can significantly slow the rate of a pandemic and limit the number of infections. But when you think about washing your hands, do you know what is actually happening? If not, let's see what's going on. First, we have to consider soap as a molecule. What does soap look like on a small scale? And how do these molecules work to clean our hands and other surfaces? Well, a soap molecule is actually kind of cool. It has one part of the molecule that is called hydrophilic, or water-loving. That means it likes to attach itself to water. The other part of the soap molecule is hydrophobic, or water-hating. This part of the soap does its best to stay away from water. In fact, it's these hydrophilic and hydrophobic properties of soap that make it so effective. Interestingly, soap does two different tasks when cleaning our hands. First, that hydrophobic tail, the end that hates water, actually loves dirt, oils, and lipids. And many germs, including viruses, are covered in a lipid membrane. Therefore, can you guess what happens when that hydrophobic tail, the part that loves dirt and lipids, comes near a virus? That's right, the tail wedges itself right into the virus's membrane and breaks it open. So what's the second way through which soap helps to get rid of germs? Once again, it comes back to the hydrophobic and hydrophilic properties of the soap molecule. When you put a bunch of soap molecules in water, they form something called a micelle. All of those hydrophobic tails of the soap molecules try their best to stay away from the water, while all of the water-loving soap heads face the outside. This creates a little pocket inside that is surrounded by water. Can you think of something else that acts like a micelle? Take a moment to think about it. I'm not sure what you thought of, but the first things that come to my mind were bubbles. Bubbles are actually a special kind of micelle. In this case, a thin layer of water is trapped in between two tiny layers of soap and keeps a pocket of air inside. Well, that is before it pops, of course. So why are these micelles so important for cleaning our hands? Well, when soap molecules are dissolved in water, they form millions of tiny micelles around the broken pieces of viruses, or any other oil and dirt on your hands for that matter. Then, when you rinse the soap off of your hands, the water washes them away down the sink. Thus, you have clean hands. Well, that is, only if you wash them properly. Many of us might wash our hands too quickly, something like this. Unfortunately, that does not do a good job of washing hands. Instead, you want to take your time washing your hands. Follow the guidelines and make sure you're scrubbing every part of your hand, including your thumbs, your fingernails, in between your fingers, the webs of your fingers, your palms, and the back of your hands. Try this at home a couple times and see if you can become an expert at it.
Well, that's it for today. Remember, be safe, wash your hands, and have fun with science. I'll talk to you soon. Bye-bye.